I'm going to do a quick mini lesson on confidence intervals. So what is a confidence interval? Well, the definition that we go with it is an interval of plausible values. Plausible values. So just like when we're doing hypothesis testing, we say something's plausible or believable. Plausible values are just the values that we're sort of confident, in this case, that a population parameter could be. They're believable. And so specifically, a confidence interval is an interval of plausible values for the population parameter. So we're coming up with, here's the range of possible values for our population parameter, either our pi or our mu. And how do we calculate that? Well, first we take a sample. So we're coming up with a range for pi and mu based on a sample that we've taken from that population. How do we write that confidence interval? There's two forms. The first way is called the margin of error form. And the format is we take that observed statistic that we took that representative sample, either x bar or p hat, plus or minus what we call a margin of error. This is sort of the wiggle room. It's like, okay, yeah, we took a sample and we got an x bar or a p hat, but it could be higher or it could be lower. So we're giving a range of plausible values. So it can be the form x bar plus or minus the margin of error. All right, that's because we have quantitative data. We have x bars, or p hat plus or minus the margin of error for categorical. And then interval notation is really just rewriting this form up here, all right, by doing this algebra. So we write it with these parentheses and we say, what's the lowest value that the estimate could be and the highest value? Well, like I said, we just do this addition and subtraction here. We take our observed statistic, either our x bar or our p hat, and for the lower end, we subtract the margin of error, minus the margin of error. For the upper end, we take our x bar or our p hat and we add the margin of error to it. So we're just doing that plus or minus. So the observed statistic is always in the center of the interval. Here's kind of what it looks like if we drew it on sort of a number line. The center of the interval is going to be x bar or p hat. If I added the margin of error, it's just sort of this distance from the center, our observed statistic, to the upper end of the limit and our lower end. So we really just get three values. We have, here's the low end of the estimate, here's the upper end, the middle is always going to be that observed statistic that I got from my sample. The margin of error is just the distance from the center to the upper level, the center to the lower level. So why do we do this? Why do we even do this? Well, let's go back to when we did hypothesis test. We wrote our hypothesis. We said, all right, the claim in this case is pi equals 0.08. Alternatively, we think that pi possibly doesn't equal 0.08. We take a sample and we get a p hat of 0.05. Our sample size is 240. We do a hypothesis test where alpha equals 0.01. We put it in the applet here, pi equals 0.08, my n, my sample size. It creates this distribution. The center of that distribution is at my assumption for the hypothesis, pi equals 0.08. But my p hat is 0.05 right here. And because it's a two-sided test, up here. All right, so if my p hat is 0.05, we've determined here, we see that our p-value is 0.10. It's bigger than our alpha value, right? 0.10 is bigger than alpha. So we conclude that the null is plausible. It's believable that pi equals 0.08. But we've only determined that for one p-value, 0.05. What a confidence interval does is it says, okay, let's take that observed statistic. I've already determined here from my hypothesis test that it's believable, right? That my null is believable. I want to say, yeah, well, I determined that for this one specific value, but what about 0.04? Is 0.04 believable? Is 0.06 believable? We're trying to come up with an interval or a range of plausible values, not just for the 0.05. So we take that observed statistic and we create this interval. Now the center, so we say, okay, we took a sample, my p-hat's 0.05. I'm essentially, instead of creating a null distribution, I'm creating a distribution around p-hat. So p-hat's in the center, and then I almost create these, right, two standard deviations. I say, okay, if I want to know with 95% confidence, I can create this distribution. I can create these cutoff values between 0.02186 and 0.07184. And the way that I do that is I can use the principles that we did for two standard deviation method. I can calculate one standard deviation for categorical data. I would use this formula. We happen to have categorical data. If I had quantitative data, I'd do this form. So in this case, I'm putting my p-hat in. 0.05 times 1 minus 0.05 divided by 240, that's my n. This is one standard deviation. If I multiply it by 2, I get the margin of error 0.2814. It's just this distance from the center to this cutoff value. Here it is in interval form. The low end is 0.2816 right here. That's this line here. The upper end is 0.7814 here. It just shows you the values that if it falls in between here, I can be 95% confident that it's plausible that pi will be between those values. All right, I'm going to skip that page. Here's my summary page that I went through in class. If we look at an example, we have 19 people that were asked how much they spent on their child's last birthday gift. It was roughly bell-shaped, meaning it's normally shaped curve with a mean of 41, standard deviation of 15. My sample size is n, and we want to use an 80% confidence interval using the theory-based inference applet. All right, so first off, is it categorical or quantitative? Well, we're talking here about we had a mean from our sample, so that means it's quantitative. Did I take one sample or two? I took one sample. So that means we're dealing with X bars because it's quantitative. My sample size is 19. My sample standard deviation is 15. And I'm using a confidence level of 80%. So if I go on my theory-based inference applet, I'm going to pick one mean. I'm going to enter my data here. N is equal to 19. My X bar is equal to 41. The standard deviation of that sample is 15. I want to make sure I select confidence level here. We before have been using significance, test of significance. I want to take confidence level. I'm going to put 80 here. All right. This is what it's going to spit back to me. What does that mean? It means that I have an interval here. The center of it is going to be at 41. It's always in the center. The low end is going to be at 36.42. The high end is going to be at 45.58. My margin of error is just the distance from the center, or my X bar, to this upper end. 45.58 minus 41, is going to give me 4.58. If I did the math here, if I did 41 minus 36.42, I'm also going to get 4.58. All right, so this is my margin of error. It's just the distance from the center to the upper end. All right, let's look at what it's asking. So it says, we are 80% confident that the average or the mean amount that all people spend on their child's last birthday gift, mu, is between these two values, between $36.42 all the way up to $45.58. That's what the tool calculated, the range. I can be 80% confident that that's how much people spent. My sample statistic is $41. The margin of error, that's what I had to calculate here. It gives me this range out of the tool, gives me the low end and the high end, but I know that the center is at my X bar. I can calculate the margin of error. I did that here. It's $4.58. And then down here, it just wants me to take what I calculated in part B and C. I'm writing it in the form X bar plus or minus margin of error. X bar is 41. My margin of error is $4.58.